Hi, good morning everyone. So I'm Dr. Chandra Prajapati, Associate Professor in the Department of Civil Engineering, Science Institute of Technology. Previous class we have derived the expression of we have moved the Pascal law, and then we solved some problems related to fluid pressure. So today we are going to do some more problems related to pressure measurement. So first problem is the third problem. Previous class we have solved two problems. Now we are going to from the third problem. So the problem is an oil of specific gravity of 0.9 is contained in a vessel at a point. The height of the oil is 40 centimeters. So find the corresponding height of the water at that point. So what is asking is an oil of specific gravity 0.9 is contained in a vessel. So there is a vessel. So it contains an oil. For example, this is some oil with a specific gravity. The specific gravity of an oil is given as 0.9. The height of the oil is 40 centimeters. So the height of the oil is 40 centimeters. The height of the oil is 40 centimeters. Find the corresponding height of the water at that point. So, for example, what is asking is, so there is a vessel which contains an oil of specific gravity 0.9. The height of the oil is 40 centimeters. So it exerts some pressure, right? It exerts some pressure at the bottom of the vessel. So what will be the corresponding height? Corresponding height means here to exert the same pressure. So what would be the height of the water? So if we replace the oil with the water, what is the height to exert the same pressure exerted by the oil of specific gravity 0.9? So okay, we will try to solve it. So we know that the formula for pressure. So P is rho P H. What is rho here? Rho is density of a fluid, and G is acceleration due to gravity, and H is height of the fluid. So do you know the density of the oil? No, right? We don't know. And G we can measure as 9.81 meter per second square. And H is we know 40 centimeters. So first we need to find out rho value. How to find out the rho? So we already discussed in the first class like fluid properties, right? There are expression for fluid properties. So we know the specific gravity of a fluid. The specific gravity of the fluid is nothing but it's the ratio of density of an oil. Density of a fluid divided by the density of standard fluid. That means water. So this is the formula. We know, right? Now we know the specific gravity of the fluid. That means oil. This we know. And density of the fluid we need to find out. So what is the density of the water? So we know that density of the water is nothing but 1000 kg per meter cube. Right? Density of the water, density of the standard fluid is 1000 kg per meter cube. If you substitute these values here, you will get how much? So the specific gravity, so 0.9 will be equal to density of the fluid by density of the water. How much? 1000. kg per meter. So if you multiply, then you will get density of the. So you will get the density of the fluid will be how much? 0.9 into 100. So 1000 it will be 900 kg per meter cube. This is the density of the fluid. Right? Now your task is to measure the pressure, right? P. So we know we need rho, G, H, rho. We calculated here, and G we can assume, and H we know. So if you substitute these values in the pressure, you will get the pressure created by the oil with a height of 0.9. Sorry, with a height of 40 centimeters with a specific gravity of 0.9. So what is the pressure here? P equal to rho G H. That means rho is 900 and G is 9.81 and H is 40 centimeters. Converted into meters, it will be 0.4 meters. Because why we have to convert into meters? Here the density of the fluid in kg per meter cube. So that means we have to multiply with 0.4. Now we will get the value of the pressure. Okay. How much it is? It is okay. This is the density of the pressure of the oil. This is the pressure of the oil. Okay. Now our task is to find out the corresponding height of the water. So that means so there is a pressure. Again, it is contained in the water. The same pressure which contains the water. So to exact the pressure, how much this pressure, right? So pressure is 900 into 9.81 into 40. This is the pressure exactly by the fluid. So what would be the height? So this height we need to find out. How much of water can be here to exact the same pressure? So that means again the same formula, V is equal to rho G H. Pressure we know. How much pressure? 900 into 9.81 into 40. What is the density of the water? We know 1000 kg per meter cube into the value we know, right? 9.81 into H. Right? So 9.81 we cancel. So yeah, this will be so 0.9 into. So what is the H value? 0.9 into 40. That means 36 centimeters. Sorry, oh, it is in centimeters. Here I calculated. So H is 36 centimeters. So this is the head of the water required to create to get the same pressure created by the oil with the density of 0.9 with 40 centimeters. So 36 meters to head of the water is sufficient to create the same pressure. I hope you understand this problem. So we will go for second one. Right? Okay. The next problem is an open tank contains the water up to depth of 2 meters. So there is an open tank which contains the water up to depth of 2 meters. So there is a tank. It contains the water up to depth of 2 meters. Above it, an oil of specific gravity 0.9 for a depth of 1 meter. Okay. Yeah, see. So what is saying, an open tank contains water up to a depth of 2 meters. So there is an open tank. So which contains the water. So this is the water up to a depth of 2 meters. So above it, an oil of specific gravity 0.9 for a depth of 1 meter. So for 1 meter, there is an oil. This is an oil. So bottom there is a water and top there is an oil with a specific gravity of 0.9. Specific gravity of 0.9. So you have to find out the pressure intensity I. Okay, you need to find out the pressure intensity. And where we have to find out? First one is at the interface of the two liquids. That means here. At the interface of the two liquids. So we need to find out the pressure intensity here, Pi. Right? At the bottom of the tank. So here, right? Pressure intensity at interface and at the bottom of the tank. Okay, at the interface and at the bottom of the tank. So these two we need to find. Okay. First, try to find out here. What is the formula for pressure? We know, right? P is equal to rho G H. Do we know the density? Already we calculated the similar problem. Specific gravity of the oil, we know 0.9. So, what is the density of the fluid here? Density of the fluid is specific gravity into density of the water. That means 0.9 into 1000. That is 900 kg per meter. Right? Now we know the density, that is 900, and acceleration due to gravity 9.81, and height. What is the height of the oil? This is 1 meter. So now you will get a pressure intensity at the interface. If you multiply, then you will get an answer. So it's approximately 81. What's the pressure intensity here? It will be 8829 Newton per meter square. Right? It is 8829 Newton per meter square. Now, we need to find out the pressure at the bottom. So pressure at the bottom means total pressure, right? So it will be, what is the pressure at the bottom? Pressure intensity at the top plus pressure created by the water. That means rho water into G into head of the water. That means 8829 plus density of the water is 1000 into 9.81 into head of the water is 2 meters, right? So you will get pressure at the bottom. So it is around 28,449 Newton per meter square. 28,449 Newton per meter square. Right? This is the pressure. Okay, again I will shortly review. So there is open tank with the water at depth of 2 meters, and above it there is an oil with a depth of 1 meter. So with the specific gravity of 0.9, you need to find out the pressure at the interface, pressure intensity at the interface, that is Pi, and pressure intensity at the bottom, that is P. So how we calculate? We know that P is equal to rho G H, right? This is the formula for pressure. So we are calculating the density of the fluid, and then we calculate the pressure. Similarly, here water pressure means pressure here, right? So this is the relative pressure, right? This pressure and this pressure. So then we added the pressure intensity interface and pressure intensity created by this water. So we get the total pressure. Yeah, I hope you understand this problem too. Yeah, now we will try to solve another important problem. One of the important problem in this concept. So find it. Okay, the problem is the diameters of a small piston in a large piston of hydraulic jack. Okay, there is a hydraulic jack. So there are two pistons. One is a large piston, another one is a small piston. Are 3 centimeters and 10 centimeters. So here, the diameter of the small piston is given as 3 centimeters, and diameter of the large piston, this is given as 10 centimeters. Okay. A force of 80 newtons applied on the small piston. So there is a force. So 80 Newton force is applied on the small piston. So find the load lifted by the large piston. Okay, the question is, there are a hydraulic jack. So there are two pistons, one is large and small pistons. Sorry, there are two pistons. Okay. So when he applied 80 Newton pressure on the small piston, so how much weight the large piston can lift? So this is one of the applications of the Pascal law. Right. What is asking is, there are 2 points. One is the pistons are at the same level. So the piston, the two pistons, large piston and small piston are at the same level. So how much weight the large piston can lift if I apply 80 Newton pressure on the small piston. The second one is that the small piston is 40 centimeters above. So that means, so here it is. So it is filled with liquid, and this piston is lifted up 40 centimeters above. Okay, 40 centimeters above the large piston. Okay. 40 centimeters above the large piston, then how much weight it can lift. So these things you need to find out. So first we are trying to solve the problem when the pistons are at the same level. Okay. Yeah, see, this is the diameter is 3 centimeters and this diameter is 10 centimeters and here it is 80 newtons. Okay. Now, when the pistons are at the same level, okay. Now, first what we need to know, there are 80 newton forces applied on the small piston. What is the area of the small piston? So first we need to find out the area of the small piston. That is pi by 4 d square. That means pi by 4 into d means 3 centimeters, right? So that is 0.3. Okay. Next, what is the area of the large piston? The area of the large piston. The area of the large piston is pi by 4 d square. That is pi by 4 into 0.1. This is 3 centimeters, right? That means 0.03. Okay, this is 10 centimeters. So that means 0.1 meters. Now you will get an area of the small piston and area of the large piston. So what is the pressure intensity created by the 80 newtons when you apply on the small piston? So pressure is force per area. Force per unit area, right? What is the force? 80 newtons. What is the area? Pi by 4 into 0.03. How much it is? 7.068. 7. This is so this is 7.06 centimeter square, 78.24 centimeter square. So what's the area? It is 7.06. That means you will get a pressure of how much? 80 by 7.06. So it is. Oh, we will keep it here. So this is the pressure intensity. But according to the Pascal law, see when the pressure is same at the same horizontal surface. These are at the same level, right? So what are the pressure created here? It will be equal to the pressure applied here, right? So what is the pressure? So what is the pressure at the large piston? So pressure is equal to weight by area of the large piston. Area of the large piston. So what is the pressure? Same pressure, right? So that means it is 80 by 7.06 will be equal to, what is the weight? That we need to find out. Weight, what we need to find out? The load lifted. The load lifted, that means weight we need to find out. So what is the weight? That we need to find out. Area of the large piston is 78.24, right? Yeah. Now, so what is the weight? Weight equal to 80.7.06 into 78.24. Now you will get a weight. Okay, now you will get a weight. That is around 880.96. So this will be 880.96 newtons. This is the weight. Okay. So if you apply 80 newtons on a small piston, it can lift up to 889, approximately 889 newtons, when the diameter is varies, right? Almost 3 times, more than 3 times. Okay. Okay, this is the first part of the question, right? Okay. I hope you understand. Now we will move to second part. Yeah, what is the second part? The second part is when the small piston is 40 centimeter above the large piston. Okay. Now we will come here. So again, earlier the two pistons are at the same level. Now the difference between the two pistons, it is 40 centimeters. Now how much weight it can lift, right? Okay. Now again we will do the same thing. See. So what is the pressure at level AA? What is the pressure intensity? Pressure intensity at level at AA. What is the pressure intensity at the level AA? When you 18 newtons is applied. Again the pressure applied is same, right? 18 newtons is applied. Okay, the force applied is 18 newtons. The area we already calculated. Area of the small piston is 0%, 7.06 centimeters square. So area of the large piston is 78.24 centimeters square. Okay, we already calculated all this. Now, what is the pressure intensity at the area? So it is the pressure for unit area. Pressure created by the piston plus pressure due to head of the water, 40 centimeters head of the water. That means rho GH. Rho GH. Okay. Now, what type of liquid is there? The diameter of small piston, large piston. The density of the liquid of the jar is given as, see the density is given here. How much? 1000 kg per meter cube. So the density of the liquid is given. Right? That we will use. What is the density of the liquid? So this we know, right? F by A. So 80 by 7.06 plus the density of the fluid is already given in the problem, that is 1000 kg per meter cube. That means it is the water. Right? Now what is the G? We will assume 9181 and H. What is the head of the liquid? Is 40 centimeters. So we will use 40. Now we will get the pressure at AA. This is the pressure at AA. So the same pressure, according to the Pascal law, at the horizontal surface, the pressure intensity is same, right? So the same pressure will be applied here. Okay. So what is the pressure at large piston? So it will be pressure is equal to weight by area. So we need to find out the weight and pressure we know, right? The same area pressure will be here. So that means it will be 80 plus 7.06 plus 1000 into 9.81 into 40 will be equal to how much? Weight for area. So weight divided by 78.24 centimeters square. So all are in centimeters. So what will be the weight? So the weight will be, right? If you calculate the value and multiply with 78.24, you will get the weight. So what is the weight? So it will be 919.7 newtons. 919.7 newtons. So how much pressure extra, how much extra weight we can lift it because of the force? There is a difference of 40 centimeter height of the liquid between a small piston and large piston. So it will be 919.7 minus 58.96, right? This is the weight lifted because of the difference of liquid levels. I hope you understood this problem